Hello, and welcome to this overview of the changes to the 2023 Dry Floodproofing Certificate form. Here's our agenda for today. We'll provide some background on the Floodproofing Certificate form, connect the flood insurance rating methodology and international building codes to the updates. Next, we'll provide a refresher on the key definitions and the floodproofing regulations in the Code of Federal Regulations. Finally, we'll walk through the updates to the 4 sections of the Floodproofing Certificate form. The Dry Floodproofing Certificate form is utilized both for floodplain management requirements and for insurance rating. The form is for non-residential structures and for dry floodproofed non-residential portions of mixed-use structures. It's used by a registered professional engineer or architect to certify 3 things: the elevation to which the building has been dry floodproofed, that the building is watertight with walls that are substantially impermeable to the passage of water, and that it is appropriately designed and constructed to resist flood forces. Updates to this form and others are performed on a cycle, which creates an opportunity to align them with emerging information and provide additional clarifications or instructions. FEMA has updated the NFIP insurance rating methodology, leveraging industry best practices and cutting-edge technology to enable FEMA to deliver rates that are actuarially sound, easier to understand, and that better reflect a property's flood risk. FEMA now has the capability and tools to incorporate more flood risk variables to define a property's unique flood risk. Multiple flooding types, the cost to rebuild a particular structure, as well as geographic variables and a building's characteristics or structural variables are considered. A property's prior claims history and other mitigation and statutory discounts are also included in the calculations. One of those potential discounts is for dry floodproofing. Here's a brief list of some of those building characteristics or structural variables, many of which are captured on the elevation certificate. Then there are various types of flood insurance discounts that could apply when a property owner takes mitigation steps to help reduce flood damage to the property, or when certain construction elements or thresholds are met. For example, there are discounts for certain foundation types, for proper elevation of machinery and equipment, or for being in a CRS participating community. In the case of a non-residential building, or a mixed-use building that's properly dry flood-proofed, a policy discount may apply where appropriate. The Flood Insurance Manual describes that the NFIP requires a floodproofing certificate to consider the floodproofing mitigation measures in rating a building. This means you must have this certification to determine if you're eligible for that flood insurance discount. Eligibility for a floodproofing discount is not just in the special flood hazard area anymore. FEMA is expanding those policy discounts, making them available to properties outside those high-risk flood hazard areas. So in non-coastal special flood hazard areas, those zones starting with the letter A, as well as outside of the SFHA, in zones B, C, D, or X, floodproofing discounts are going to be available. This discount is not available in V zones because dry floodproofing is not allowed in V zones. The instructions on the form specify the expanded availability of the discount. The performance standard of 1 foot above the base flood elevation, or BFE, in the special flood hazard area is still listed. Plus, for non-special flood hazard area zones, the performance standard of 2 feet above the natural highest adjacent grade, or HAG, is the performance standard for eligibility for credit. We'll come back to this performance standard when we talk about the sections of the form. While the form we're talking about in this video is for non-residential structures, please note that there are very rare cases where communities have an exception from FEMA for dry floodproofing residential basements. there are not very many of these across the country. They must have specific language in their local ordinance, and they must pass a technical review by FEMA before approval. This is defined in 44 CFR Section 60.6. For these rare cases, there's a separate residential form, the NFIP's Residential Basement Floodproofing Certificate. For more information, please visit FEMA.gov. Another reason for updating this floodproofing certificate is to reflect building code requirements. While the minimum National Flood Insurance Program requirement is dry floodproofing to the base flood elevation, building codes that many states adopt do go beyond that minimum. The international codes have provisions that constitute higher standards, such as freeboard, and ASCE 24 talks about flood-resistant design and construction. This engineering consensus standard has been incorporated by reference by the I-codes since 2000. Although some states don't require adoption of the I-codes, FEMA still recognizes this as the national standard, and thus as the threshold for eligibility for that flood insurance discount. According to ASCE 24, the minimum elevation for dry floodproofing is to at least to the base flood elevation plus 1 foot. ASCE 24 also specifies that dry floodproofing measures are not allowed in coastal high hazard areas, coastal A zones, and other high-risk flood hazard areas. These measures are also not allowed for residential structures. This information helps floodplain administrators in determining the appropriateness of dry floodproofing in each area. Some of this data was not previously captured on the floodproofing certificate, so an update to the form was needed. In summary, key updates to the form relate to the NFIP flood insurance rating methodology, needing data the old form did not provide. Due to the expansion of policy discounts available to properties located outside the SFHA, we now need information about those areas. This addition also clarifies questions related to the building code and the ASCE 24 standards, which the form didn't previously capture. Finally, this updated form will better capture the information needed to help floodplain managers determine whether dry floodproofing is even appropriate in an area. Before we get into the form section by section, let's revisit some key definitions and some of the regulatory basics in CFR about floodproofing, specifically dry floodproofing. Floodproofing is defined as any combination of structural or non-structural additions, changes, or adjustments to structures, which reduce or eliminate flood damage to real estate or improved real property, water and sanitary facilities, structures, and their contents. You'll notice that this definition does not specify wet or dry. In the NFIP regulations and the expanded guidance that discusses how this is done, floodproofing is understood to refer to dry floodproofing, rather than the wet floodproofing approach of letting floodwaters enter and flow through a structure. Let's highlight that distinction between wet and dry floodproofing. Wet floodproofing is those structural measures that provide resistance to flood damage while fully allowing the floodwaters to enter that structure or area. Here, we're typically talking about things like flood openings or breakaway walls for enclosures below the BFE, along with flood-resistant materials and methods in those enclosed areas, as well as the proper protection of mechanical and utility equipment. Under the NFIP, wet floodproofing is limited to enclosures below elevated structures that are used only for storage, parking, and building access. It's also allowable for accessory or agricultural structures that have been issued variances for wet floodproofing by the community. Dry floodproofing, by contrast, is the type where we're trying to keep water out of the building. This is not going to allow floodwaters to pass through. Those enclosures use special sealants, components, equipment, coatings or doors or panels, shields or pumps to keep it watertight and substantially impermeable. That's what this dry floodproofing certificate is for. Dry floodproofing is an approach that is not appropriate in all areas or for all uses. It's not permitted for residential structures or for any structures in those coastal high hazard areas where the buildings are subject to added wind and wave forces. The Code of Federal Regulations tells us who can take this approach and what the standard of performance is. For non-residential buildings or non-residential portions of mixed-use buildings, dry floodproofing may be permitted as an alternative to elevation in those non-wind and wave action zones. If that dry floodproofing path is taken, then the appropriate certification is required. You will need a registered professional engineer or architect to review the design, specifications, and plans to verify the construction is in accordance with the accepted standards of practice. This is a foundational reason for why we have the Dry Floodproofing Certificate. The local floodplain administrator is required to maintain a record of those certifications. Language from the CFR is reflected on the purpose and introduction page of the Floodproofing Certificate. A bit of new text in the instructions recognizes that there may be other higher state and local requirements that also need to be addressed or considered when ensuring that dry floodproofing is an appropriate or viable flood protection measure in an area. There are many things to consider when choosing whether or not to take a dry floodproofing approach. Let's review what substantially impermeable actually means. FEMA Technical Bulletin 3 and our engineering design standards acknowledge that in a building designed to be watertight, seepage through different points of entry might result in some accumulation of water during flooding. ASCE 24 says a structure is considered substantially impermeable if it is not allowing more than 4 inches of water to accumulate on the inside of the building in a 24-hour period, without relying on active devices for the removal of the water. As you can tell, this is different from wet floodproofing, where we're allowing all of the water in. Here, we're trying to keep all of the water out, but we recognize there may still be a little bit of seepage. There is not a one-size-fits-all approach to dry floodproofing. There are many different measures, or combinations of measures, that can meet this performance standard. It could be just doors and windows, or panels, or just seals, or a combination of those things. FEMA technical bulletins and guidance documents provide discussions of when it might be appropriate to use this approach. Floodproofing might be appropriate or applicable to core areas of critical facilities, buildings that are non-residential and subject to frequent low-level flooding, new non-residential construction, or non-residential portions of mixed-use buildings. Again, dry floodproofing would be most successful in those areas that do not have high velocity flooding and do not have very deep flood depths. Because there's not a one-size-fits-all approach, FEMA has detailed guidance about what performance standards must be met for a structure to be considered appropriately dry floodproofed. Engineering calculations, methods, and standards are found in FEMA Technical Bulletin 3 and in Publication 936 about floodproofing non-residential buildings, as well as in Publication 2037, Flood Mitigation Measures for Multifamily Buildings. A determination of whether something is dry floodproofed will involve technical analysis and justification. This is much more about data, backup documentation, and an assessment of components, so we need a registered engineer's signature and seal to certify that design is in accordance with ASCE 24. The local floodplain administrator uses this in their permit review process and will keep that documentation in their permit records. Next, let's talk about the form itself. The Dry Floodproofing Certificate for Non-Residential Structures form now has 4 sections, plus a few pages for instructions. The new form was implemented on July 7, 2023, and is currently available for download at FEMA.gov. The previous version of the form has been approved for use until November 1, 2023. The form has 4 sections, with expanded instructions that provide additional clarity on the required documentation that must be attached. there is no section for the public or homeowner to certify information on this dry floodproofing certificate form. This is a form used by engineers and other licensed professionals. The instructions specify the dry floodproofing approach for non-residential buildings, and that for mixed-use buildings, it might be appropriate to dry floodproof just those non-residential portions on the lower floors. The instructions provide a detailed listing of the required documentation that must accompany this certificate. Also included in the expansion to the instructions are updated web addresses for relevant guidance documents and updated links to FEMA's Flood Map Service Center. Section 1 is for the flood insurance rate map or FIRM information. In comparison to the prior version of the form, we're now collecting additional property information and additional information off the FIRM with better descriptions of the hazards. In this section, we're still collecting information that describes the property. There's now a row for building use. This is important because the dry floodproofing approach is applicable only to certain types of structures. There's a new row for the latitude and longitude, as well as the horizontal datum. On the FIRM information portion of Section 1, we're collecting both the community name and community ID, or CID number. This helps ensure FEMA is appropriately applying the correct participating community in which the structure is physically located. There's a prompt here for multiple flood zones and base flood elevations for sites where there might be a bit more nuance to what's going on. For example, there may be a larger commercial structure partially in an AO zone and partially in an AE zone. In this case, there would be multiple flood zones and BFEs or depths that would apply. The form is also asking specifically about the source of the BFE or depth. We're now collecting information on 3 elements of flood hazard details. These tie directly back to ASCE 24 and the thresholds for determining when dry floodproofing is appropriate. First is the limit of moderate wave action, or LMWA. If that line is shown on the FIRM, we're going to check a box indicating so. Then we want to make sure we understand the location of the building in relation to that LMWA line. This ties right back to the ASCE 24 standard. Here we're looking to demonstrate whether a building is landward of the LMWA, where dry floodproofing is permitted, or waterward of that line, where it is not permitted. Next is regulatory floodway. If you've got a structure in or partially in a regulatory floodway, indicate that here. Obtain the velocity in the area of that building. Then we'll verify if the velocity is underneath the threshold that would make it ineligible for that mitigation discount credit. Finally, for sites located in an alluvial fan, you must indicate both the depth and the velocity of the water. Here's a walkthrough example for each of those 3 elements. For the LMWA, the form asks, is there a limit of moderate wave action shown on the FIRM? Yes or no? In example structure A, there is a limit of moderate wave action shown on the FIRM. Note that the arrows that point towards the open ocean or shoreline indicate the waterward and landward directions for this particular map on the left. For structure A, we would label this yes on the FIRM and show that it is not located between the LMWA and the Zone V boundary or shoreline. This one is landward of the LMWA, so indicate no in the second box. Property B is waterward of the LMWA line. In this case, on the form you would say yes and yes. With example C on the right, if you're having trouble finding the LMWA line, it's because there isn't one. In this case, we would just say no on the form, because there is no limit of moderate wave action shown on the FIRM. For regulatory floodways, we'll refer back to guidance in FEMA Publication 936. It specifies that we can get these approximations of velocity from the data in the floodway data tables in the flood insurance study. As an example of what that looks like, here are a few fictional structures that are partially or completely in a regulatory floodway. In this case, we'll check the box for yes on the form. Then, we need to go and get some more information from the flood insurance study. Find the floodway data tables for the appropriate flooding source and confirm you're looking at the table with the correct riverine cross-sections. When determining the BFE, we know that we cannot interpolate between wavy lines on the map for the BFE. For the floodway velocity piece, guidance tells us that we can interpolate those approximations of velocity from the data in the FIS data table. So, property 1 is located between cross-sections AH and AG. So we'll go to the floodway data table and find the mean velocity column. We can interpolate between 4.8 and 3.8, so we'll say that's about 4.3. Again, we're rounding to the same nearest tenth of a foot found in the data tables. Property 2, on the other hand, has a narrower regulatory floodway. Between cross-sections AJ and AI, we see 8.9 and 7.8. So we're looking at about 8.3 or 8.4 for our floodway velocity here. In both cases, we would indicate yes for velocity and then provide the number at the building location. Of course, this would be in addition to all other floodway development requirements, including no-rise analysis. Doing this exercise for the dry floodproofing certificate does not substitute for an H&H floodway encroachment analysis for a proposed building. For our alluvial fan example, note that these AO zones have both a depth and a velocity printed right on the form. So we would say yes on the form, and then we'd provide the depth in one blank and the velocity in the second blank. Why collect this additional information? The floodplain manager is going to use this data for floodplain management purposes, but it's also useful for underwriters for verifying the eligibility for that dry floodproofing discount. Remember, the minimum NFIP standards don't specify the limits based on the depth, velocity, or the presence of waves, but the FEMA technical bulletins and ASCE 24 do. FEMA does not recommend use of those dry floodproofing systems in areas where the depth of water is greater than 3 feet, where the velocity is too high, greater than 5 feet per second, or in coastal A zones waterward of LIMWA with breaking waves between 1.5 and 3 feet. There are now separate sections for design or pre-construction certification, as well as for finished construction elevation. There are different requirements for what professionals can complete in each section. Section 2 is our new section, and it is for floodproofed design certification. It sets up the answers needed about the floodproofing methods that we're asking a registered professional engineer or architect who is licensed in that state to certify. The form asks what the dry floodproofing approach is, and to describe the result of that floodproofing approach. The comments and description box has space to capture this description, the design elevation, and the adjacent grades. Remember, this is prior to construction. Because there are multiple ways to meet that dry floodproofing performance standard, it's important to tell the story of the proposed methods and measures here, and report the results or targets that that approach will meet. There are feet or meters indicator boxes, and you'll also be indicating natural grade or finished grade for the lowest and highest adjacent grades. These are collected right next to the building. Reinforcing the need to certify pre-construction design, here are some diagrams from various FEMA publications on those performance standards. This diagram shows how there might be some seepage, even in a dry floodproofed building where we're trying to keep all the water out. If we have less than 4 inches of water accumulating in a 24-hour period, ASCE 24 says that's substantially impermeable. Is the building capable of resisting all those flood forces? Hydrostatic and hydrodynamic forces? What about the effects of buoyancy? And are there appropriate flood damage resistant materials anywhere where there could be some seepage? Section 3 is for as-built certification. This confirms the as-constructed conditions or the elevation the building is dry floodproof to. The height above the lowest adjacent grade is also collected, with checkboxes to specify natural or finished. We're also documenting highest adjacent grade, specifically natural highest adjacent grade. That's because inside the special flood hazard area, we're looking for 1 foot above base flood elevation, and outside the special flood hazard area, at least 2 feet above the natural highest adjacent grade. That's the performance standard to be considered for dry floodproofing credit. The height of that floodproofing on the structure above the natural or finished lowest adjacent grade is also written as an indicator here. It should match the difference between your floodproofed elevation and your lowest adjacent grade elevation. There's a new checkbox prompt if a conversion factor is used. If the datum used was different between the firm information and the building elevations collected, then the surveyor or licensed professional is prompted to check that box and describe the conversion factor in the comments area of this section. The notes have also been expanded for this section with the detail about the performance standard for dry floodproofing credit. 1 foot is subtracted from the dry floodproofed elevation, so a building in the special flood hazard area must be dry floodproofed to at least 1 foot above the BFE to be considered for floodproofing credit. And for those locations in zones B, C, D, or X, the building must be dry floodproofed to at least 2 feet above the natural highest adjacent grade to be considered for that dry floodproofing credit. Finally, Section 4 is where we put it all together. Section 2 said, here's what we're shooting for in the design. Section 3 says, here's the as-built elevations and adjacent grades. And Section 4 is where the engineer or architect says, I'm here to tell you that those 2 things together are enough. This section certifies both the design and the construction based on as-built drawings, the design specs, and a physical inspection of the finished construction of that building. No additional data or numbers are entered or collected here. This is just a signature and a seal for the engineer or architect to certify their assessment. The instructions for Section 4 have been expanded. It's still specifying, showing that the building is in accordance with accepted standards of engineering practice, that it is substantially impermeable to the passage of water, and that all of the structural components are capable of resisting flood forces. There's a bit of new language that specifies the use of flood damage resistant materials in places where seepage may be expected, and clarifying that the as-built is in accordance with the design and any alterations to the design. If something had to change between design and as-built, this is a prompt to make sure that the information from design in Section 2 and finished construction in Section 3 considers and incorporates that alteration. To have that reasonable assurance that the engineer or architect did their due diligence, there's a lot of information that must be provided as backup documentation with this certificate. You can see there is a lot of detail and many specific instructions about the needed documentation. Photographs, a comprehensive emergency operations plan, an inspection and maintenance plan, and a building owner acknowledgement letter or form are all needed. Here's a summary slide for each of those types of required documentation. For photographs, the form has more explicit detail about the multitude of photos wanted in order to be able to tell the story of how that dry floodproofing was achieved. What measures were used? What kind of components were used? Can we see all sides and aspects of the building wherever possible? Take photos of all the different elements, the barriers, the shields, where they're deployed, where they're stored, and so forth. Someone should be able to review the photos and verify the information provided in the design and construction specs. Here are example photos from FEMA Publication 2037. We can see the close-up of a sealed door, and then the broader hallway photo of the lower enclosed area. The photos together show near and far the story of this dry floodproofing measure. Lots of new specifics about documentation for a flood emergency operations plan are provided for the entire structure. This plan must include a number of different things, including but not limited to who and what you need to deploy the system, what personnel and equipment you need, and the sequence and timeline of what triggers the installation. Who gets notified? Who is responsible for which elements? Where are these things stored when they're not being used? Under what conditions do they get deployed? Where are the personnel and evacuation plans? How often is testing or drill running or staff training occurring? The plan should show also that there is a regular review and update of the plan and the procedures. The comprehensive inspection and maintenance plan should have details for the entire structure, inside and out. Inspecting and maintaining any joints, seals, cracks, or structural elements. Checking the doors, panels, and sump pumps, or emergency backup systems. It even goes as detailed as getting the manufacturer's contact info so that you can get replacement parts or repairs. This plan should also be maintained and updated regularly as needed. The final required document is a building owner acknowledgement, which becomes a separate document or letter on letterhead attached to the form. There's no official acknowledgement form for this. We want a letter that verifies the owner is aware of the criteria for when those dry floodproofing measures must be installed and how to do it, and that they're familiar with the emergency operations plan and the inspection and maintenance plan. Additionally, if the measures are going to be installed by a third party that the owner is working with, then the third party must also sign an acknowledgement form. Copies of all pages of the Dry Floodproofing Certificate form and the required documents as attachments go to the community official to keep in their records, to the insurance agent and the underwriter, and to the building owner. The insurer submits the required dry floodproofing documentation to FEMA, and FEMA reviews it and determines if everything submitted allows for eligibility of that dry floodproofing credit. The submittal includes an application form, a completed elevation certificate, a completed dry floodproofing certificate, as well as the required attachments. Remember, the dry floodproofing certificate is not a substitute for the elevation certificate. Information must also be submitted annually to validate that continued eligibility for floodproofing credit. There's a set of questions that have to be answered at renewal each year for recertification by FEMA. This is typically done with a letter on letterhead from the inspector, confirming the re-inspection date and what was inspected, that the inspection and maintenance plan has been reviewed and updated, and that the comprehensive flood emergency operations plan has been reviewed and updated. The updated documentation must be submitted to the email box NFIP Underwriting Mailbox at fema.dhs.gov at least 120 days prior to the renewal effective date for any non-residential renewal receiving a floodproofing discount. The next update to the flood insurance manual will have an update about this in the How to Renew section. In summary, these updates to the Dry Floodproofing Certificate form involve collecting additional information that ties directly to the requirements of ASCE 24, those national engineering standards. It helps us determine where that dry floodproofing approach is viable and where that building is eligible for the dry floodproofing discount, both inside and outside of the SFHA. There's now a separate Section 2 for design or pre-construction review. The as-built elevations are collected in Section 3, and then Section 4 puts it all together, where the engineer certifies that both the design and the construction meet the performance standards. Finally, the updated form has many more specifics provided on the required supporting documentation and photos that must accompany this certificate. Thank you for watching this overview of the changes to the 2023 Dry Floodproofing Certificate form. If you have questions about the form, please email them to nfip underwriting mailbox@fema.dhs.gov.